We all know the story. A lone genius peers through a telescope, discovers the truth of the cosmos, and is ruthlessly silenced by a dogmatic, anti-science religious authority. But the actual historical record, as documented by modern historians, suggests that this black-and-white narrative of the 1633 trial is an invention of later centuries. The trial documents reveal a much more complex dispute over the nature of evidence. Galileo stood before a tribunal that demanded physical proof for a theory he could only support with elegant, but mathematically incomplete, geometry. This suggests that the popular story of the Galileo affair hides a reality that feels backward to us today. In the 17th century, the Church's demands for empirical proof actually aligned closer to the scientific method than Galileo's own claims. This diagram shows the accepted Ptolemaic geocentric model of the era. It places a stationary Earth at the center of the universe, surrounded by the concentric spheres that carried the planets and the Sun. Galileo championed the alternative, the Copernican heliocentric model, which put the Sun at the center. We often assume this model won out because it provided a much cleaner explanation of the night sky. But this page from Copernicus's own De Revolutionibus reveals a mathematical nightmare. Copernicus stubbornly maintained the ancient dogma that all heavenly bodies must travel in perfect circles. To make his data match the stars, his system required 48 invisible epicycles. An epicycle is a theoretical, smaller geometric circle that a planet travels along while traversing its main orbit. Furthermore, observers in the 1600s looked for stellar parallax, the apparent shift in a star's position when viewed from different points in Earth's orbit. Without physical evidence of this shift, most scientists concluded the Earth simply wasn't moving through space. Early 17th century observers viewed heliocentrism as a messy mathematical hypothesis. Without a way to measure the movement of the stars, the Earth appeared to be exactly where it had always been, perfectly still. While Galileo argued for his model, contemporary Johannes Kepler discovered the true solution to planetary motion. Kepler realized that planets travel in elliptical or oval-shaped orbits. Galileo dogmatically ignored Kepler's discovery. He remained committed to his own belief that heavenly bodies could only move in perfect circles, dismissing Kepler's accurate mathematics as a failure. This diagram illustrates the Tychonic system, a viable compromise model favored by many astronomers. In this setup, the planets orbit the Sun, and the Sun orbits a stationary Earth. It accounted for every telescope observation Galileo made without requiring the Earth to move. Galileo also mocked Kepler's accurate theory that the moon's pull caused the ocean tides. Instead, Galileo invented a mechanically flawed theory, claiming the tides were simply water sloshing around due to the physical rotation of the Earth. By rejecting superior mathematical models and ignoring accurate physical data, Galileo was fighting for his own personal assumptions rather than an objective scientific truth. In Rome, the Inquisition's leading theologian, Cardinal Robert Bellarmine, was evaluating the debate with a sophisticated set of logic rules. Under the Bellarmine principle, the Church officially permitted the Copernican model to be taught and utilized as a mathematical hypothesis, a useful tool for calculations. Bellarmine set a clear standard. Biblical passages, such as Joshua commanding the sun to stand still, were understood to describe a stationary Earth. If Galileo could provide conclusive physical proof for heliocentrism, the Church would willingly reinterpret those passages. Lacking the physical proof the cardinal requested, Galileo demanded the Church immediately alter its roles for biblical interpretation to fit his unproven theory. The conflict centered on the rules of evidence. The Church maintained its theological requirements for a theory Galileo could only defend with a failed mechanical model of the tides. In 1633, the Inquisition brought Galileo to trial, leveling specific written charges against him. The court labeled his model foolish and absurd in philosophy. This meant that by the rigorous scientific standards of the era, he had failed to provide the empirical proof required to call his theory a physical reality. The Inquisition labeled him formally heretical for overstepping his authority. By privately reinterpreting scripture against centuries of tradition, he had violated a direct order to remain within the realm of mathematics. Ultimately, Galileo was condemned for failing to use the scientific method he is often credited with inventing, and for attempting to dictate theology from a position of scientific weakness. Modern philosopher of science Paul Feyerabend argued that our common understanding of this trial is fundamentally inverted. Feyerabend reached a startling conclusion. The Church at the time of Galileo kept closer to reason. Its indictment was rational. He argued that based on the evidence available at the time, the Church made the logical choice. The actual Galileo Fair serves as a warning. It highlights the dangers of scientific arrogance and the temptation to present a favored theory as absolute truth before the facts are in. True progress requires epistemic humility. This was the exact standard the Church's rational parameters demanded, and it was the one thing Galileo refused to provide.